In this video, we're going to talk about the conic section ellipse. What is an ellipse? The set of all points whose sum distance from the two fixed points, called foci, is constant. We can visualize this in the following way. Let two thumbtacks represent the foci and a string be the constant sum of the two distances. Pull the string, taut with a pen, and draw all the way around the foci. So as described in the picture. Every ellipse has a major axis, the longer axis, that passes through the center, foci, and the vertices, and every ellipse has a minor axis, the shorter one, that determines the width of the ellipse. So with this basic concept, we are going to determine when we will say an ellipse has a vertical major axis versus a horizontal major axis. If the y term has a larger denominator, then we say that the major axis is vertical. If the x term has a larger denominator, then we say that the major axis is horizontal. The standard equation for ellipses are y minus k squared over a squared when a is greater than b, and plus x minus h squared over b squared equal to 1. Since a is greater than b, the y term has a larger denominator and it is the vertical major axis. The center for this ellipse is h comma k. The vertices are h comma k plus or minus a, and the foci are h comma k plus or minus c. So for an ellipse with a vertical major axis, you change only the y coordinate. Similarly, if a is greater than b and the ellipse is of the form x minus h whole square over a square plus y minus k square over b square equal to 1, then the center is h comma k. And this time you change only the x coordinates to get the vertices and the foci. So you say h plus or minus a comma k and h plus or minus c comma k are vertices and foci respectively, where c, the constant, is called the eccentricity of the ellipse. And to calculate c, we use the formula c squared equal to a square minus b square. Now, as we have seen during parabola, these things make way more sense if we actually work on problems. So we'll go start working on problems. A circle is a special type of ellipse. Its major and minor axes are same in length. So find the center and the radius of the circle. We did these problems previously. Let's try to work it out again. So x squared minus 4x, so you write it as 2 times x times 2 will make it minus 4. So I need 2 squared and I have to subtract 2 squared. Then I look at y and I write it as y squared plus 2 times y. This time I only need times 1. So I need 1 squared subtract 1 squared is equal to 4. First 3 terms is x minus 2 whole to the power 2 minus 4 plus y plus 1 whole to the power 1, and that's these 3 terms, minus 1 equal to 4. So I write it as x minus 2 squared plus y plus 1 squared is equal to 4 plus 4 plus 1, which is 9. So write it as x minus 2 squared plus y plus 1 squared equal to 3 squared, which is 9. That tells us the center of this circle is 2 comma negative 1 and the radius is 3 units. That's what we see as the picture given in the handout as the picture of this circle. So the next problem is asking us to find the center, vertices, foci and sketch the ellipse. So first and foremost, I have to make the right hand side 1. So what I will do, I will divide both sides by 225 and I will get 9 times x minus 5 whole to the power 2 over 225 plus 25 times y plus 1 whole to the power 2 over 225 equal to 1. 9 divides 225 and I get x minus 5 whole to the power 2 over 25. Plus 25 divides 225 and you get 9. So write them as squares. So you say x minus 5 whole to the power 2 over 5 squared plus y plus 1, or actually at this point write it as y minus minus 1 to give it the standard form, square over 3 square equal to 1. So A is 5, which is greater than 3, and that is the B. So the major axis is horizontal. Because the denominator under x is larger. So now we're going to find the eccentricity, C, and remember that is going to be a square minus b square, so it's 5 square minus 3 square. So 25 minus 9, so that is 16, so 4. So now we are pretty set. We are going to say center of this ellipse is going to be 5, negative 1. And since it has the major axis horizontal, we're going to change the y coordinates. We're going to change the x coordinates all the time. So to find the vertices first. And remember the formula is h plus or minus a comma k. So I'm going to write it that way. I will say h, which is 5, plus a, which is 4. So 9, negative 1. And h minus a, which is 5 minus I'm so sorry. I'm using a, so h is 5 and a is also 5, so it's 5 plus 5 comma k and 5 minus 5 comma k. So that tells me the two vertices are 10 negative 1 and 0 negative 1. Then foci, and this time you use c and you do h plus or minus c comma k. So you do 5 plus 4 negative 1 and 5 minus 4 negative 1. So you get 9 negative 1 and 1 negative 1 as the two foci. And then finally, we're going to draw this situation. So first and foremost, the vertex of there are two vertices of this ellipse, and these are 10 negative 1 and 0 negative 1. So let's do that. 10 negative 1 is here, 0 negative 1 is going to be here. So these are the two vertices. The major axis is going to be 2 times A, so 10 units long, that's from 0 to 10. The minor axis is going to be 2 times B, so 6 units long. And the vertex of the center of this ellipse is at 5, negative 1. So this is the center. And then, as I said, 3 units up and down for the minor axis. So 1, 2, 3, so here, and 1, 2, 3, so here. And that is going to give you the shape of this ellipse. Something like that. And the foci to focus are at 9, negative 1 and 1, negative 1. So this is 1, negative 1 and this one is 9, negative 1. These are the two foci. And that completes this problem for us. So we level everything. So this is 1, negative 1, 9, negative 1. This is 10, negative 1. This one is the other vertex, 0, negative 1. The center is at 5, negative 1. These two are both 3 units, and that's the minor axis. Should have been a little careful because I have to go to the center. So that's what I meant. All right. So let's see whether we can do our next problem. This problem again given in the general form, so probably will require us to complete the square. So 3x squared plus y squared plus 18x minus 2y minus 8. So first and foremost, what I would like to do is to complete the square, we will say 3x squared plus 18x together plus y squared minus 2y together and put the 8 on the other side. Then from the 3, x squared and 18x factor out 3, get x squared plus 6x. And y squared minus 2 times y times 1, so I need 1 squared. and I need minus 1 square is equal to 8. So I get 3 times x squared plus 2 times x times 3 to complete the square this time. So I need 3 squared and subtract 3 squared again. And then I remember these terms all together is going to be y minus 1 whole to the power 2. Don't forget the minus 1. So you get 3 times again, these 3 is going to be x plus 3 whole to the power 2. Then I have minus 9, but then you have this 3 outside, so 3 times minus 9 is minus 27, plus y minus 1 whole square is equal to 8 plus 1. I took that minus 1 by adding on both sides. Now I'm going to do the same, I'm going to add 27 on both sides. So 3 times x plus 3 whole to the power 2 plus y minus 1 whole to the power 2 is equal to 9 plus 27. And that is 36. So now I'm going to divide both sides by 36. So we'll get 3 times x plus 3 over 36 plus y minus 1 whole to the power 2 over 36 is equal to 1. What does that tell me? Well, it tells me all the information. So see, the denominator for x is going to be 12. So if I want to write it in the new format, I will say this is y minus 1 squared over 36, so that's 6 squared, plus x minus minus 3 whole to the power 2 over 3 divides 36 gives you 12, so you can write it as square root of 12 squared. So clearly, the denominator under y is larger, so the major axis is going to be vertical. So this ellipse is going to be vertical major axis. And then we will start working from there. So A is 6 for this ellipse. B is equal to square root of 12 for this ellipse. So C is going to be square root of A squared, which is 36, minus B squared, which is 12. So that's square root of 24, which I can write as 2 square root of 6. So that tells me that now I can talk about the center of this ellipse. And the center is going to be h comma k. So that's going to be 1 comma negative 3. Vertices, there are 2 of them, and they are going to be, since it is a vertical major axis, you are changing only the y coordinates. So it's going to be h fixed, so negative 3 comma 1 plus or minus a, and a this time is 6 units. So they are going to be negative 3 comma 7 and negative 3 comma negative 5. So these are your vertices, negative 3 comma 7 and negative 3 comma 5. Now foci, that's going to be negative 3 comma 1 plus or minus c, and the c is 2 square root of 6 units. So they're going to be the 2 foci, 1 plus 2 square root of 6, negative 3, 1 comma 1 plus 2 square root of 6, and negative 3 comma 1 minus 2 square root of 6. So let's see whether that matches with the given situation. First, the vertex of this ellipse is at 1 comma negative 3. So it should be x equal to negative 3. That's the center, I'm so sorry. Center of this ellipse is at clearly negative 3 comma 1, and see that matches with our work. It's negative 3 comma 1. It's here. The 2 vertices are at negative 3 comma 7, which is here, and negative 3 comma negative 5, which is here. The foci are at 1 plus 2 square root of 6, which is somewhere here. And the other one is at 1 minus 2 square root of 6, which is near negative 4. So that has done this problem for us. and this ellipse is going to be of this shape, and we're done. So let's see whether we can work on the next problem. Find the standard form of the equation of the ellipse given the vertices are 1, 8 and 1, -8, focus at 1, 4 and 1, -4. And you just have to use one of those things. So first and foremost, since h is not changing, you can at once say that h is equal to 1. Since you are changing k, that means it is going to be vertical major axis. And what I'm supposed to understand? Vertices are k plus a. K plus a is 8. And focus is k plus c. And that is equal to 4. Whereas k minus a is equal to -8. And k minus c is equal to -4. So from these two equations, k plus a equal to 8 and k minus a equal to 8, I get 2k equal to 0, so k is equal to 0, and that simply means a is equal to 8. From these two equations, you get 2k equal to 0, since k is equal to 0, c is equal to 4. So c square is equal to 4 square is equal to 16 is equal to a square, which is 64, minus b square. That helps us find the value of b. So b square is equal to, so in this situation I have found out that b square is 64 minus 16, and that is equal to 48. So that tells me when I take the square root, b is going to be square root of 48, and you can at any point write it as 4 square root of 3. I wanted the standard form of the ellipse, so now I can go ahead and say that the standard form of the ellipse is going to be, remember it has the vertical major axis, so y will have bigger denominator, so it's y minus k, so y minus 0 square, over a square, which is 8 square, plus x minus 1, that's your h, square, over b square, which is 4 square root of 3 square, and that is equal to 1. So that's the form of the ellipse. So let's try to draw the graph of this ellipse. All the points are kind of noted for us. We have found out that the center is at the point 1, 0, so it's here. So the form of the ellipse is going to be something along this line. It passes through the vertices. But then I need to know how much will be the width of this ellipse. So remember the minor axis is 4 square root of 3 units. So that is a little less than 7 units. So if this is your center, go almost 7. So 1, 2, 3, 4, 5, 6, 7. So almost here. And same thing on the other side. So that's going to be 1, 2, 3, 4, 5, 6, 7. So here. So that's how we get to understand the shape of this ellipse. And that has done it for us. And we can carry on to our next example. Okay, so this one says find the standard form of the equation of the ellipse given the focus is 2, 1 and negative 2, 1 and the major axis is of length 8. So first and foremost, you are not changing k, you are changing h. So you know that the major axis is going to be horizontal. That tells me that the denominator under x is the larger one. Now the major axis has a length of 8, remember that's 2a. So now I know a is equal to 4 units. I have been given with the focus, so first k is equal to 1, and then I know h plus c must be 2 units. H minus c must be negative 2 units. If I add these two, I get 2h equal to 0, so h must be 0. What else I know? That tells me the vertices, because the vertices are h plus or minus a comma k. So then I know that the vertices are 4 comma 0 and negative 4 comma 0. Also, it tells us the value of b because we know c square is equal to a square minus b square. Remember, c is 2 units because h is 0. That means 0 plus c equal to 2. So c is equal to 2. So c square is 4. I know a is 4. So that's 4 squared. So 16 minus b square. So b square is 16 minus 4. So b square is 12 units. So b is equal to 2 square root of 3 units. Which is a little more than 3 but less than 4. So that's your minor axis. So the two foci are given to me, negative 2 comma 1 and 2 comma 1. We have found out the vertices are at negative 4 comma 1. I'm so sorry again. It should be negative 4 comma 1 and 4 comma 1 because k is 1. So they are here and here. The center is h comma k. So for this ellipse, the center of the ellipse will be given by h is 0, k is 1. So it's 0 comma 1, which is here. And then think about the minor axis. The minor axis, as we have talked about, has a length more than 3, less than 4. So I'm going to go, this is 1, 2, 3, a little more than 3, so say here, and then 1, 2, 3, so say here. And then I kind of do this thing, joining these points, and then that gives us the picture of the ellipse. Okay, and if I wanted to write down the equation of the ellipse, then it will be, since I did not change y and it has horizontal major axis, I'll first write x minus 0 square over a square plus y minus k, which is 1 square, over b square, which is 2 square root of 3 whole to the power 2, equal to 1 as the standard form of the ellipse. Okay? Find the center and the radius of the circle. So this one is again back to a circle, special type of ellipse. So I will say x squared minus 4x plus y squared plus 6y equal to 23. So write it as x squared minus 2 times x times 2 plus 2 squared minus 2 squared. That completes the x terms. Plus y squared plus 2 times y times 3 plus 3 squared minus 3 squared equal to 23. So now I have completed both. So it's x minus 2 whole to the power 2. Then I have negative 4 plus y plus 3 whole to the power 2. And then I have minus 9 equal to 23. So write it as x minus 2 whole to the power 2 plus y minus minus 3 whole to the power 2 equal to 23 plus 4 plus 9, which is a 36. And finally, I will write it as x minus 2 square plus y minus, or y minus minus 3. That will be easier to find out the center. Y minus minus 3 square, quantity square, is equal to 36. So you can write it as 6 squared. So the center is going to be 2 comma negative 3, and the radius is going to be 6 units. So if I have to draw the picture, I will go to 2 comma negative 3 first. X equal to 2, y equal to negative 3 is here, and then I will draw the circle, which will go to 6 units as radius. So that kind of justifies the picture, where the center is given by 2 comma negative 3 and the radius is 6 units. Okay, so let's see what is number 7. Find the center, vertices, foci, and sketch the ellipse. So again, this one requires you to complete the square, and we will be a little careful. First, group the terms with x. So 25x squared minus 100x. Then the y's, 16y squared plus 96y. Take the constant term to the other side. Now factor out 25 from the first, 2, so it's x squared minus 4x. Factor out 16 from the second pair of terms, so this is y squared plus 6y equal to 156. So I do 25 times x squared minus 2 times x times 2 plus 2 squared minus 2 squared to complete the x terms. Similarly, plus 16 times y squared plus 2 times y times 3 plus 3 squared minus 3 squared, and that completes the y term. So I get 25 times x minus 2 whole to the power 2, that's these three. Then I have minus 4 times 25, so that's minus 100. Now y plus 3 whole square, so plus 16 times y plus 3 whole square. Then you have minus 9 times 16, so that's negative 144 equal to 156. And as I know, I will take both of these constant terms to the right hand side and write it as 25 times x minus 2 whole to the power 2 plus 16 times, I will make it y minus minus 3 equal to 156 plus 144 plus 100. So 156 plus 144 is 300 plus 100 is 400, and I will divide both sides by 400, so I will get 25 times x minus 2 squared over 400 plus 16 times y minus minus 3 squared over 400 equal to 1. So now I have the standard form of the ellipse, almost. Write it as x minus 2 squared over 25 divided by 400 is 16 on the bottom, so I write it as 4 squared plus y minus minus 3 whole to the power 2, 25 on the bottom this time, so 5 squared is equal to 1. So this one is going to be horizontal major axis. How come? Because a is 5 and that's the denominator to the y term, and that is greater than 4, which is b. So eccentricity, c is square root of a squared, so 25 minus b squared, so 16. So that's square root of 9, and that's 3. Helps us understand the vertex, 2 of them. So vertices are going to be h. This time you're changing the value of h only, not the k. So it's h plus or minus a. So I'm going to say h is 2 for us, plus or minus, oh actually this is horizontal, so you're not changing h, you're changing k. So 2 will be fixed, comma, k plus or minus a. So that's negative 3 plus or minus a is 5 units. So these vertices are 2, comma, negative 3 plus 5 is positive 2, and negative 3 minus 5 is negative 8. Okay? So, and I said horizontal, it actually should be vertical. Again, remember the denominator under y is the larger one. That's why I'm changing the k coordinate. I'm so sorry. Okay. So these are my vertices. The foci, since they are h comma k plus or minus c, I will say 2 comma negative 3 plus or minus 3. So there are 2 comma 0 and 2 comma negative 6. And of course the center of this ellipse is h comma k, which is 2 comma negative 3. So let's put these points in. So 2 comma negative 3, x equal to 2, y equal to negative 3. Let's see, 1, 2, 3, 4, 5. So 2 is here. That's the center. Now I do the vertices. They are 2 comma 2 and 2 comma negative 8. 2 comma negative 8 and 2 comma 2. Foci are at 2 comma 0 and 2 comma negative 6. So 2 comma 0, 2 comma negative 6. Minor axis is 3 units, which tells me that actually minor axis is 4 units. So which tells me that the width of this ellipse is going to be 4 units. So from the center, left and right go 4. So 1, 2, 3, 4 here. and 1, 2, 3, 4 here, and then I can complete the ellipse. So here and here, and I say the shape is something along this line, and that is my ellipse, and we're done. Okay. Find the standard form of the equation of the ellipse satisfying the given condition. The endpoints of the major axis are 3, 12 and 3, 0. Endpoints of the minor axis is 8, 6 and negative 2, 6. So what I will do, first I will try to understand from the major axis which coordinate I'm changing. So I'm changing the y coordinate, and the change is 12 units. So A times 2 is 12 minus 0. So 2A is equal to 6. And since the major axis you are changing the y coordinate, those are the two vertices. That means this is a vertical ellipse with a vertical major axis. So A I know is 6 units. Similarly, I can find B. Now see, for B, you did not change the y, you changed the x, and the total change is going to be this. So 2b is going to be 8 minus minus 2. So 2b is 10, that means b is 5 units. And that pretty much has set everything for us. Now we are interested in knowing the vertex. So clearly the vertex is going to be 3, 6. From the major axis says that the vertex, I'm sorry. From the major axis, when we were changing the y, we did not change the x coordinate, so h is 3, if that helps. And for the minor axis, we were changing the h, not the k, so k is 6. So the center is at 3, 6. What does that mean? It means that the ellipse is going to be of the form y minus 6 whole to the power 2. And remember, the major axis is y-axis, or the vertical axis. So a squared, which is 6 squared, plus x minus 3 squared over the minor axis is b, so 5 squared equal to 1. And we are done with the standard form of this ellipse. Find the standard form of the equation of the ellipse satisfying the following condition. This time I know that the major axis is of the length 6, the minor axis is of the length 4. So clearly I have 2a given to be 6 units. So a is equal to 3 units. And minor axis 2b is equal to 4 units. So b is equal to 2 units. Center, so h and k are given to me. And that is 5, 4. And it says the major axis is vertical. So that answers your question. You say y minus 4 squared over the larger denominator, so 3 squared, plus x minus 5 squared over b squared, so 2 squared equal to 1. And that is the answer to this question. Okay? So that concludes our study of ellipse, the conical section, and it also concludes parabola, circle and ellipse. The next one, which is a little different than the concepts of circle and ellipse, but more closely associated with the concept of parabola, is going to be studied, and it's called hyperbola.